For section 11.1, we're looking at areas of triangles and parallelograms. We're also going to include a couple other shapes in here as well. We're going to look at rectangles and squares. So we first have a few postulates to start the section. If we could just we're going to use them throughout the way as we go, but we're not really going to think of them too much. It's kind of a used rule we can apply. The first one is the area of a square is the square of the length of its side. So if I have a square, I know all the sides are the same. I have right angles. So I could square the side length because, well, they're all the same side length, and I'd get its area. We've seen that before when we've talked about the Pythagorean theorem proof. And this is where we took the side lengths and squared them. Hypotenuse squared equals leg squared plus leg squared, and we got a literal square, so we looked at the area. So that's where we've applied it before. You could also treat this as a rectangle, and we'll talk about the rectangle formula in a bit, but really it's just multiplying the two dimensions. Postulate 25 says the area congruence postulate. If two polygons are congruent, then they have the same area. So if we have congruent shapes, areas will be the same. We could apply this, maybe it's a problem where we're looking at floor tiles. And if we know the area of one of them, and all the tiles are the same, then we could just maybe take those areas, add them all together, or even multiply in that sense. Postulate 26 is probably one we'll use more, and that's the area of the region is the sum of the areas of its non-overlapping parts. So let's say I have a shape that looks like this. I'm not going to have a formula for that one, but what I could do is break it up to two parts, such that it's a rectangle and now a triangle. Or I could go further and break that triangle up into two more parts. In any case, this area, this sum of the areas, and this sum of the areas would all be the same because I can combine these areas to equal the whole thing. So it's something we can use if we don't have a formula for the whole thing, but maybe we can break up the parts and find it. Now, first two we have are the rectangles and parallelograms. Both of them are going to have the same formula. Area is base times height. A key thing we're going to notice throughout these formulas for this section and the following section is this relationship between these values we are multiplying. In a rectangle, the base and height are separated by a right angle. In fact, all the angles are perpendicular. And what we find is when we multiply these two values, we're multiplying them and there's a right angle there. Base and height, multiply the two, we get our area. If we look over at the parallelogram, we have a base, a height. Those are perpendicular to each other. It's the height of the parallelogram. It is the distance between the parallel sides, because those sides are parallel in a parallelogram. Not this side out here. This side is not perpendicular to the base. It's not perpendicular to the height, so we're not going to use that. Now, that's not a clear rule we have. They have to be perpendicular. We're not going to state that, but it's something to keep in mind, something to look for that will maybe make things a little bit easier. So in either case, we look for that perpendicular, we multiply those values, and that gives us our area. And when we find area, we need to state our units squared for area, and if we're talking about just length, it'll just be the normal units, like inches, centimeters, feet, whereas inches squared would be inches squared, feet squared, meters squared. So we'll work through a few examples for this one. Every time I do the problem, I write my formula first. So area equals b times h, base times height. I plug in my values. That is 13 times 11. Now, even though this 11 is on the outside, it's still talking about the height. I can move it in here, and it's still the height of the parallelogram. I then multiply that, and I get 143 units squared for my area. Show all my steps, multiply, circle my answer, name the units. Next problem is a rectangle, so this is going to be area equals base times height. I have 16 times 10, which gives me 160 units squared. Next two problems I've kind of added a little bit to it. Now they give me the area, and I need to solve for an unknown value. I still have to write my formula as I start. Area equals base times height because it's a parallelogram. almost get into the habit of just identify what shape it is. Don't worry about the values yet. What shape is it? What formula am I going to use? Then figure out what you need from it. So base times height is what I'm going to use. I have 7.2 equals 3 times 3x, and I'm solving for x. I get 7.2 equals 9x. If I divide 7.2 by 9, I get 0.8. Now, if I was to divide 72 by 9, it would be 8. Since that decimal's over 1, I can make it 0.8, and our units would be meters. So 0.8 meters is our value for x. It's not squared because we're not looking at the area. Area was 7.2. The values on this side will just be meters, not squared. Next one we have is a rectangle. So I look, area is base times height. I have 14.3 equals, well, right here I can't really tell which one's base and height. I just know they're perpendicular, so we could just write 1/2 x times 2.2. By simplifying, I get 1.1x by taking half of 2.2. Then divide 14.3 by 1.1, and I get 13, and that's inches. 13 inches. Okay, so if we go to our next shape now, which is a triangle, we have a different type of formula. Area is 1/2 base times height. Now, if I cover up that 1/2, it looks like the parallelogram or the rectangle formula, and that is something that's a common error for a lot of students. We have to pay attention to that. A triangle is 1/2 base times height, because if we just did base and height, we'd be looking at a parallelogram or a rectangle. Now, before we see why that's the case, you could do it as 1/2 base times height or base times height divided by 2. They're the same thing. It just depends where you want to put that 1/2 or the fact you're dividing by 2. But again, base and height are perpendicular to each other. In this case, the height is the altitude of the triangle. This will occur in acute triangles. The height and base here are actual legs, but they're still perpendicular to each other. That will also work. And a third case you may see is when you have an obtuse angle. This would be your height, and your base would be there. In that case, your height could be outside the triangle, but it's still measuring how tall the triangle is. Now, back to the fact why we use the 1/2. If I strictly did base times height, like in this triangle, we said that would give you a rectangle. That would give you the rectangle, which is the base times the height, like we looked at right here. So that gives you a rectangle. We don't want the rectangle, we want half of it. So that triangle is half of the rectangle, so we want 1/2 base times height. If I look over at this one, if I draw a parallelogram with the base and height, I have this shape, which looks like that parallelogram, which was base times height. But I don't want that entire parallelogram, I want half of it. So a triangle is ultimately half a parallelogram and half a rectangle. If we look real quick at an example, I have a triangle here. Base and height I've labeled. If I had another triangle that is exactly the same, I've copied it. I can then take that triangle, put them together, and I now have a parallelogram that is base times height, which is the same as my rectangle that has base times height. But I don't want that entire parallelogram. I don't want that entire rectangle. I want half of it. So we have to take half in that triangle. So be aware of that. Think of that for a triangle. It's got to be 1/2. It ultimately comes down to knowing the correct formula. If you're not going to pick the correct formula from the beginning, you're not going to get the right answer. And most of the time, what I've seen is if you don't have that, if you get the triangle problem wrong, it's typically because you left off that 1/2. So let's work through a couple examples. First one, I have 7.5 as my height, 15 as my base. So 1/2 base times height. I get 1/2 15 times 7.5. 7.5 times 15 is, make sure I get the right value here, 112.5, and we just need to take half of that. Well, half of 112 is 56. Half of 0.5 is 0.25, so I get 56.25 units squared. That's my area. Next problem, area equals 1/2 base times height. 1/2 12 times 7. Take half of 12, I get 6 times 7. Oops, should be 7. And that is 42 units squared. Now in this problem, I'm now given the area and I have to solve for x, but I get in the habit. First thing I do is write the formula out. Now I can plug in what I know. I actually have values for all of them. We'll call my base 2x plus 1, but it really doesn't matter. It's either one. Height will be 4. First thing I'm going to do, why don't I take half of the 4 and make that 2 times 2x plus 1? I could then divide both sides by 2 and get 11 over here, which gets rid of the 2, but you could also distribute the 2x plus 1 times 2. We'll just get 2x plus 1 equals 11. I now subtract 1. I get 2x equals 10, so x equals 5 feet. Okay, last one we have here, they give us a problem, but we have to draw the diagram to go with it. So get in the habit of that. If they don't give you a diagram, you draw one. They tell us the hypotenuse is 25, a leg is 20. We need to find the perimeter and the area. Now, for perimeter, I would add up all the sides. I can't do that. I don't know all the sides. For area, it's 1/2 base times height. We can ask ourselves the quick question, are these two values perpendicular to each other? They're not, so we're not going to use them. We also see that this would be a height and this would be a base. That 25 is the hypotenuse. We're not going to use that. It's like you're looking at this example up here. So we have to solve for, let's just call that x. That value, once we have that, we can find the perimeter by adding all the sides, and we could find the area by multiplying that times 20 dividing by 2. So 25 squared equals 20 squared plus x squared gives us 625 equals 400 plus x squared. 225 equals x squared, so x is 15. So that's 15 now. I can find perimeter by doing 20 plus 25 plus 15, which gives us 60. And that'll be 60 centimeters because it's length, not area, so it's just units. And area would be 1/2 base times height. So that's 1/2 20 times 15, which half of that would be 10 times 15, or 150 centimeters squared. So be careful, make sure you do have values that are perpendicular to each other so you can find the area.